Hello students, let's start another topic of your chapter Wave Optics. The objective of today's topic is to study about diffraction of light. And the topics which we are going to discuss are diffraction of light, experimental setup of diffraction through a single slit. So what is diffraction? Before explaining it, just observe that light entering through the door. As we know that light follows rectilinear propagation, so it should travel in a straight line path. But here you can see that light bends at the edges. So light bends at the edges of the door. This bending of light is called diffraction of light. You can observe this phenomena on day-to-day life. Like here you can see in these two pictures, light is bending across the edges. So this bending of light is called diffraction of light. So what is diffraction of light? The phenomena of bending of light around the corners and the encroachment of light within the geometrical shadow of the opaque obstacles is called diffraction of light. So what happens over there? Now this is slit, means this is obstacle, and this is source of light. Accordingly, what should be there? It should be area of light, and this area should be of area of shadow. But here you can see that X and Y, this X and Y are region of diffraction, means here light bends or encroaches in the region of shadow. Similarly, here also we can see this is obstacle and this whole region should be of the shadow region. But this light enters or bends through the edges and enters the shadow area. It means here diffraction occurs, or we call X and Y as region of diffraction. This phenomena of diffraction not only observed in the light waves, but it also happens in the waves of water, or you can say water wave, where water waves also bends across the edges of an obstacle. So what are the conditions for diffraction? The condition for diffraction of light is that size of the slit or opening must be comparable to the wavelength of light. Here you can see in the diagram, if the obstacle or the slit has a larger size, you can see there is a lesser observation of diffraction pattern. But if there is a narrow slit or narrow gap, you can observe a prominent diffraction occurring over there. So the condition or the basic condition for diffraction of light is that the wavelength of the light should be comparable to the opening or size of the slit. Let us see experimental setup of diffraction through a single slit. So this is experimental setup. So this is source of light. This is single slit. For the diffraction we only required single slit. This is convex lens to converge the light, and here on the screen you can observe the pattern of fringes. From this image you can observe there the central part has the maximum intensity. This part is called central maxima, and as we move further from the central part, the intensity goes on decreasing. So these are called secondary minima or maximas. Now diffraction pattern on screen. In this diagram you can observe diagrammatic representation of diffraction, and this diagram you have to draw in your examination also. This is slit, or you can say width of the slit from where parallel waves or plane wave front enters. This convex lens is there to converge the light wave. You can observe here the graphical representation of maximum intensity. At this point O, you are getting maximum intensity as we have seen in the previous diagram. And further the intensity goes on decreasing, which is called secondary minima. So we will explain how we come to know what is the position of central maxima and secondary minima in the next lecture. Now let's discuss some questions. Question number 1. What is meant by diffraction of light waves? Question number 2. What is the single slit diffraction? Question number 3. Draw a diagram for the single slit diffraction experimental setup. And question number 4. Draw a diagram showing the diffraction pattern as formed on the screen with variation of intensity from the central or principal maxima to the secondary minima. That's the end of the topic. Thank you.